So if we're talking about ions, they gain or lose electrons to become noble gas configuration. All right, so magnesium 2 plus gets to be neon, or oxygen 2 minus gets to be neon. So this is actually for main group. So there's some other things here. So what if it is a transition metal or has an intervening D block? So and there's a kind of this is a special rule. Or I mean, it's not exactly special, but when removing electrons, take away the highest N electrons first. So just why is that a special rule? Because it's different from the filling order. How about titanium 2 plus? So in order to do titanium 2 plus, first let's look at titanium. What's the electron configuration of titanium? If I look at it here, it's going to be the noble gas before it's argon, and then 4s2, 3d2.
Mm-hmm.
So titanium is argon, 4s2, 3d2. And so technically when it forms an ion, titanium 2 plus would then, I would remove not the D, which was the last electrons I put in, but I would remove the higher energy level. I'd remove the S. So titanium 2 plus is going to be argon 3d2. And so they kind of skipped that on the PowerPoint. They gave you nickel and they didn't explain it, remember? So nickel was argon 4s2, 3d8. What's nickel 2 plus going to be?
Argon 3d8.
Argon 3d8. So that when as an ion, remember that the S and the 4s and the 3d are very close in energy. And as an ion, that D shell drops in energy. So it becomes the place to be, 3d8. So that's what they did. They didn't explain that. So I wanted to explain that to you. In some cases, it makes a lot of sense. Also, what if you have to lose more? How about iron 3 plus? How would we do that? Well, first you do iron, which is argon 4s2, 3d6. Aha. So how would we do iron 3 plus? What am I going to take away here?
First the 4s2.
Yeah.
And then
I take the 4s2 and I get 3d6, but then up 3 plus, I got to take away one more electron, right? So what would it actually be?
Argon 3d5.
Perfect. And so sometimes the transition metal ions will, the way they react will be to either get an empty shell like titanium, or to get a half fill. So let's actually show that. This is, we got an, oh, I guess we didn't quite do that. Titanium 4+ would be an empty shell. But they try to empty their D if they could get a D0. So actually, well, we could do one of those, like scandium. So let's do it. Let me just write next to it. Scandium would be argon 4s2 3d1. Scandium 3+ would just be argon. So transition metals can either have an empty D or a half D. Now, a lot of times they can't get to empty or half or full. And let's do zinc. So zinc is let's do argon first. Argon 4s2 3d10. So it's remember, zinc was one of the always cations. Zinc is always zinc 2+, which would be what?
Argon 3d10.
Yeah, and argon 3d10, I finished the third energy level. That's very, very stable. I've because technically in the third energy level, I can have an S, a P, and a D. And now I've filled all of them. There's no 3F. So this is having a full D. Let me put that in parentheses. These are not answers. You should, but these are kind of strategies, but you won't always get it. Like nickel doesn't get to have a full D. It just gets to get rid of the S. Same with titanium. Doesn't get to have an empty D. It just gets to get rid of its S. So they can't always do that. But a lot of times they'll react in such a way as to get an empty D if they're close to the beginning of the D block, or a half-filled D if they're somewhere in the middle, or a full D if they're toward the end. So that's kind of what transition metals do. What about lead? So I was mentioning lead earlier. Let's just do lead first. So lead is xenon 6s2 4f14 5d10 6p2. So there's two. Lead basically has two situations. There's lead 2+, which would be what? What would I do? I'm not going to touch the noble gas. What would I get rid of?
6p2.
I'd get rid of the 6p2. So I'd have 6s2, 4f14, 5d10. Basically, these ones join the core. Lead 4+ would actually be more stable. That would be the best case scenario. Xenon what?
4p.
What would I get rid of next?
6s2.
I'd get rid of the 6s2, and I'd have 4f14, 5d10. And so this is actually what they call a pseudo noble gas configuration. It's pretty stable, right? Because the main group elements will get a full, like sodium gets sodium plus. Do sodium plus gets to be neon. That is essentially noble gas configuration. Lead can't get noble gas configuration because it would have to remove another 24 electrons. So lead gets something that's quite stable called pseudo noble gas configuration. Excuse me. Okay, so that's ions in a nutshell, right? Let's continue on. Are you guys ready to continue on? All right.
Yeah.
All right. Is this making sense to everyone? Is it okay?
Yes.
So it's just a small rule, and I think it makes sense when you look at what you end with.